All right, today we're going to review Chapter 10 in preparation for a test. I'm going to try and go through it quick so that I don't have to do it in two videos, but it's possible that you'll have two videos on this. The very first section, section 10.1, we just talked about exponential fundamentals, and a lot of this stuff you had already had in the past, so this was just simply review. You know, if you have a power raised to a power, like for instance, x cubed raised to the second power, I'm going to multiply those things, which is going to give me x to the sixth. So I'm going to do the same thing over here. I have a square root of 2 times the square root of 2, which is simply 2. I have a square root of 2 times the square root of 2, which is 2, but then I'm multiplying it by this 2 right here. So that's x squared y to the fourth. Let's do another one. We're just going to have a bunch of problems that we're going to do here. Let's say I have 25, the square root of 2, times 125 times the square root of 2. Now, this is not a power raised to a power. These are two things that are multiplied. So if I can make the bases, the 25 and the 125, the same number, I can just add their exponents. They're both going to have a base of 5, so 25 is 5 squared raised to the square root of 2. And this one is 5 cubed, because that's what 125 is, raised to the square root of 2. So I'm going to multiply. This is a power raised to a power. So I have 5 raised to the square 2 on the square root of 2 power times 5 raised to 3 on the square root of 2 power. I'm going to add their exponents because the base numbers are the same. So this is 5 raised to the 5 on the square root of 2 power. All right, then we moved on in this section to equations. So I have 2 raised to the x plus 1 is equal to 2 raised to the 2x plus 3. As long as the bases are equal, we can set the exponents equal. So I subtract, I get a negative x. Subtract, I get a 2. So x is equal to negative 2. So that is your answer for that equation right there. All right, let's do another one where perhaps the bases are not equal. All right, toward the end of the chapter, we did some like this where we actually took a logarithm on both sides. You can do that to this one, but this one, there's an easier way to do it because you can make them both have a base of 2. So 8 to the third power, or 2 to the third power is the same as 8, raised to the 2n. 2 to the fourth power is the same as 16, raised to the n minus 3. I'm going to, a power raised to a power, I'm going to multiply. So this is 2 to the 6n power. This I have to distribute the 4. So that's 4n minus 12. Well, the bases are the same, so I just set the exponents equal to each other. I'm going to subtract the 4, so I get 2n is equal to negative 12, or n equals negative 6. Then we moved on to section 2. 10.2 is where we started learning about logarithms. Remember, a logarithm is another way of writing an exponential form. I'll just show you on this particular one. Let's say they give you find the log of base 4 of 64. Now, the truth of the matter is, guys, you know how to do this on your calculator now. The log of 64 divided by the log of 4 using a common log will give you the answer. But when we first started the chapter, we didn't know how to do that. So this is the way that we did it. 4 raised to the x power is equal to 64. So if I can make that a base of 4, I can just set the exponents equal to each other. This is 4 to the third power. Therefore, I know x is equal to 3. Okay, that's the same thing you would have gotten if you did this. The log of 64 divided by the log of 4. I can't unteach you that now that I've taught you that, so that's another way that you could get this answer. Okay, it's the exact same thing. All right, let's do another one. All right, now this one can't be done on a calculator because the m is not over here as far as what you're equal to. So I have to take this and I have to put it in exponential form. That's 5 raised to the 4th power is equal to m. So if I did that on my calculator, I would find out that m is equal to 625. All right, here's another one. I'm just doing all sorts of problems so that you have something to refer back to. Okay, you would also have your review sheet to go back and look at. This, I have to make it an exponential form, so it's 3 to the negative 2nd power is equal to 2c. Well, at first we're going, we can't do this. Well, yeah, I can. I can just make a number out of that. That's 1 over 9, because remember the negative 2 means it's taken to the bottom, and the 3 is squared. So I have that. In order to get rid of that 2, I'm going to divide. So I have to divide that by 2 as well, or 2 over 1. So I'm going to invert and multiply, and I get 1 over 18 is equal to c. All right, one more in this section. All right, you remember, if you have a log that's the same on both sides, and that's all you have is the log, it's almost like you're dividing by the log of 4, so you can get rid of that, and you're left with 3x minus 1 is equal to 2x plus 3, subtract, that's x, add, that's 4, so you find out that x is equal to 4. All right, then you went on to the next section, and we talked about different properties of logs. Multiplication is associated with addition. So that's like the pattern for multiplication. If I can take, let's say that's 45, I can let that be 9 times 5. I also found about that division is related to subtraction, the same thing there, except for its subtraction rather than addition. Okay, so if that was 16 over 3, it would be the log of base whatever of 16 minus the log of the same base of 3. And then the last one we learned was this. If I have a number in front of my logarithm, I can turn around and use it as an exponent on that number. So it becomes like that. Those are basically the 3 patterns that we had. Then you learned how to do, and again, you learned the shortcut later on this. So I can't stop you from using the shortcut, but they gave you like the log of base 10 of 5 is equal to 0.6990, and the log of base 10 of 7 is equal to 0.8451. And they say find the log base 10 of 25. Well, 25 is the same thing as 5 times 5. So you know that you can figure that one out. So I have the log of base 10 of 5 plus the log of base 10 of 5. Okay, and I have the value for that. So I just substitute the value here. So it's 0.6990 plus 0.6990, which gives me 1.3980. However, you also know you can do that on a calculator now. That is the log of 25 divided by the log of 10. And it's going to give you the exact same answer. All right, then we went on to section 10.4, and this was calculator use. we began to talk about the common log, which was the base of 10. And so I could use my calculator if I asked you what the log of 72.6 is. You're just going to press the log button. You're going to press that. You're going to do enter, and it's 1.8614. I also learned about the antilog of, let's say, negative 1.42. To find that, I would do second log, because it's like the inverse of log. And then I would put that in there, negative 1.42, and then I would press enter. And it's going to give me 0.0380. Make sure you know how to do those on your calculator, both the log and the antilog. Okay, the next section, which was 10.5, was the natural log. Now, the natural log has a base of e, but it's the same thing. Your calculator is what you're going to be using to solve it, and it's the LN button on your calculator, the natural log. So if I take the natural log of 16.85, you would do LN 16.85, enter, and it would give you 7.4295. You also have an anti-natural log. It's anti-LN. So if I asked you to do the anti-log of 10, anti-natural log of 10, it would be second, then your LN button, then 10, and then enter, which is going to give you a value of 22026. Okay, so both 10.4 and 10.5 are just calculator use. And then on 10.6, you learned how to do what we already just did, where you divide to solve a logarithm. So like, let's say I have the log of 14 of 126. You're going to go the log of 126 divided by the log of 14. You must put the log on both of those. That is not the same as the log of 126 divided by 14. That's not the same thing. So you have to do the log of 126 divided by the log of 14. It is 1.8326 if you want to make sure whether you can do that on the calculator. Then we started doing some equations. So let's say I have 2 to the x power is equal to 5 to the x minus 2 power. There is no way for me to make those bases the same. So what I do is I either take a natural log of both sides or a common log of both sides. It doesn't matter which one I use. I tend to use the common log. So I have the log of 2 raised to the x power is equal to the log of 5 raised to the x minus 2 power. I'm going to bring the exponents to the front. So this becomes x times the log of 2 is equal to x minus 2 times the log of 5. Now, I'm going to distribute here. I'm going to leave that as it is. So x times the log of 2 is equal to x times the log of 5 minus 2 times the log of 5. Okay, I want to bring my x's together, so I'm going to subtract that. So I have x times the log of 2 minus x times the log of 5 is equal to negative 2 times the log of 5. All right, I'm going to factor out the x, so I have the log of 2 minus the log of 5 equals negative 2 times the log of 5. Well, this is multiplied by the x, so to get rid of it, I'm going to divide. Goes away there. All right. To get the answer, all you have to do is put that into your calculator, but you need to be very careful, okay? The calculator is going to put the beginning parenthesis you need to put the in parentheses. Then you can put the divide, but you can put a divide right here in your calculator, but then this needs to be in parentheses, but remember you're gonna have parentheses inside other parentheses. So that's gonna be a calculator problem. If you feel more comfortable, do this, write it down, do that, write it down, then use your calculator to find an answer. The answer here is 3.5129. Make sure you can do that and you get that out on your calculator. This is about using your calculator correctly. All right, last problem and then I'll give you your homework. Say I have 7x to the 9/8 power is equal to 111. Well, before I start taking logarithms, I want to get rid of what I can get rid of. I'm going to divide the x. I'm going to divide this by 7, so I get that by 7. So I have x raised to the 9/8 power is equal to 111 over 7. Then I'm going to take the log of both sides. All right, gonna bring this to the front, so I have 9/8 times the log of x is equal to the log of 111 over 7. And what I'm gonna do is I'm gonna divide both sides by 9/8, which is the same thing, and I'll go ahead and do this. It's the same thing as multiplying by 8 over 9, because I'm going to invert and multiply. So I'm left with the log of x, and what I would do is I would go ahead and do that on my calculator, okay? This is going to be 111 divided by 7, and then you're going to multiply it, and I would do parentheses around that, by 8/9. I should get 1.0669. Well, notice I still have a log on this side. So what I'm going to do to solve for that is I'm going to take the inverse of it, or do the antilog. So it's the antilog of 1.0669 is going to give me the value for x. So x is going to equal 11.66. That's going to be just a little bit different. Okay, but understand, I'm looking for that number. So the log of what number is going to give me that? That's the same as saying the antilog of this number gives me the x. It's like the inverse of it. All right, homework. Page 638 through 640. 8 through 74 even. A lot of that's calculator use.